Hey there everyone, welcome to Solving Systems of Equations by Substitution. Here we are going to do 3 variable problems. In the previous video I did just 2, so check that out if you haven't seen that one yet. Let's just get started. So you have 3 equations, and you see in those 3 equations you have an x, y, and a z. The key is to just find an equation to solve for one letter and then plug it into one, and then you'll have to get an answer and plug that into another. So it's determine what's maybe easiest to solve for. In this case, I think you got a couple of options, but I think the best option is probably the top equation because it has the least amount of variables. All right, so that'll make it a little bit easier, I would think. So I'm going to write down 3y minus 6z equals negative 6, and I'm going to just solve for y, because why not? So I'll add 6z to the other side, and I get 3y equals 6z minus 6. So if I divide everything by 3, because you got to split up a number and a letter by dividing, that'll leave me with the equation y equals 2z minus 2. So now anytime I see the letter y, I can plug that in. So I got 2 equations. The other 2 equations have the letter y in it. So I am going to replace the letter y with 2z minus 2. And so let me fix this y. I just made it worse, but oh well. So I have x minus, and then I'm going to plug in the 2z minus 2, because it said x minus y, plus 4z equals 10. All right? So if you have a minus sign in the outside, it's going to distribute to everything. So it says x minus 2z. And then minus a negative 2 turns into plus 2. And then I'll bring everything else down, so plus 4z equals 10. So at this point, we should combine our like terms, negative 2z and 4z. So that'll just make a positive 2z, so x plus 2z, oh, and don't forget about that plus 2, equals 10. And then I can just minus this 2 over there. So x plus 2z equals 8. So what you'll want to do here is solve this equation for x or for z, whatever you want, because we have an equation solved for y. So we need to solve. We need to have an equation solved for one of the other 2 letters, solve for x or solve for z. So it looks like it's easier to solve for x at this point. So I'm gonna minus 2z over. All right, and then I have x equals negative 2z plus 8. So now I have an x equals equation. And then up here, I still have that y equals equation. That's still valid. All right. So I'm going to look at the third equation now. And it says 2x plus 2y minus z equals 12. Except anytime I see the letter y, I'll plug in 2z minus 2. And anytime I see the letter x, I'll see negative 2z plus 8. And if you notice, the letter y, it only has the letter z in it, in its equation, and then when I solve for x, it only has the letter z in that equation. So that's really going to help us going forward in this third equation. So let me show you what it looks like. So instead of 2x, I wrote 2 parentheses negative 2z plus 8, because that's what x was, and then it said plus 2y, so I wrote plus 2 parentheses, and then y was 2z minus 2, so 2z minus 2. And then I carried down the minus z equals 12. Sorry for the background noise. People are moving furniture next door. All right. I can't do anything about that. So now let's just distribute everything, combine our like terms, solve for z, and we'll have one of the 3 variables solved. So we have 2 times negative 2z, that's negative 4z. 2 times 8 is 16. Then you have 2 times 2z, so that's 4z. And then 2 times negative 2 is minus 4. And then I'll bring down the minus z equals 12. So let's combine our like terms. I got negative 4z plus 4z minus z. So negative 4z plus 4z makes 0. 0 minus z makes a negative z. And then I have 16 minus 4. 16 minus 4 is 12. So negative z plus 12 equals 12. So if I minus 12 to the other side, it says negative z equals 0. And so, you know, when you have a negative, you would divide by negative 1, or you flip the sign. 0 is neither positive nor negative, so you can just say z equals 0. Okay? So at this point, we have a y equals equation, we have an x equals equation, and we have the value for z. So I'm going to plug in 0 into the y equals 1. So that was 2z minus 2, so it's 2, let's change the color, let's go with blue. 2z minus 2 is 2 times 0 minus 2. So that's going to equal negative 2. So that's y. So put a little y equals there. All right? And then I go down to the x, and x is negative 2z plus 8, and x equals negative 2 times 0 plus 8. So that's 0 plus 8, so x equals 0. I mean 8. It's 0 plus 8. 0 plus 8 is 8, not 0. Okay, so we have our 3 answers. So the first one did take a long time to get to, but then the other 2 were really quick. Just plug it in and we got it. Okay, so what you want to do at this point is rephrase your answer as an ordered triple. An ordered pair is the intersection of 2 lines. An ordered triple is like an intersection on a 3-dimensional plane. So it's 8 comma negative 2 x comma y comma z, 0. And that's the final answer. Okay, moving on to letter B. This top equation should say 4x. That was a typo on my part. So fixing that right now. So I have 3 variables present in all my equations, okay? So I'm just going to work from the top equation. I'm going to pick a variable to solve for. I feel like it's easiest to solve for the letter y because it's just a plus y. There's no negative sign by it. There's no number by it. So it's the easiest variable to solve for. So I'm going to rewrite the equation, the very top equation, and then I'm going to solve it for y. And so that means I have to minus 4x, over. And then I also have to add z over. And so I'll put plus z right there. All right, and that's going to cancel these out. And so it's going to make y equals, and you can write it in whatever order you want, but I'll just put it in order with the letters, negative 4x plus z, and then add that plus 2 at the end. At this point, you'll want to plug this in to the very next equation. So this is a y equals statement, so I'm going to plug this in to the letter y right there. So it's going to say 4x, and since it just says plus y in that one, there's nothing to distribute, so I don't even have to write parentheses. You only have to write parentheses if you're distributing a number or a negative or both, but if it just says plus y, you can just carry it down. So minus 4x plus z plus 2 plus z equals 2. So let's combine our like terms. 4x minus x makes 0, and then it says z plus z. So 4x minus x makes 0, and z plus z makes 2z. And then I have plus 2 equals 2. So I can minus 2 over, and then that says 2z equals 0. So if 2 times z is 0, then z must equal 0, because 0 divided by 2 is 0. Okay, so you have z equals 0. Plug it back into one of your equations. Let's go and plug it into the third equation. We can plug z equals 0 in right here, and then we can plug this y equals statement right there. So here's what it's going to look like. 12x plus 3y, so plus 3 times negative 4x plus z plus 2, all that. Minus 3z, so minus 3 times 0 equals 6, Okay, so I'm going to distribute. So I have 12x minus 12x plus 3z. Oh, look, I should have done this. I should have erased the z and plugged in a 0 for z. So it's like 3 times 0 is 0, so that makes 0, so I don't need this 3z term here because that's 3 times 0. And so I can just jump ahead to this 3 times 2. That's going to be 6, so plus 6. And then I had this minus 3 times 0. Well, that's 0 as well. So I'm going to write equals 6. So if you notice, our x variables cancel out again. 12x minus x makes 0. And so you're left with this statement, 6 equals 6. Anytime your variables all cancel out and you have a number equal itself, that's a true statement, 6 equals 6. This is a special case kind of problem. It's infinitely many solutions, okay? It'd be easier to see on the graph if you were to graph all three of these equations. You'd see one line. But we're not looking at the graph, we're looking at it algebraically. So you're going to have a weird looking answer like this. A number equals a number. So that's going to be, again, that's going to be infinitely many solutions. So yeah, that problem's actually done. I don't have to do any more work on that one. Okay, so this video is running a little long, but I got 2 more examples to do, so stay with me. Looking at these 3 equations, the top equation just has a plus z. That looks like it's the easiest thing to solve for, so I'm going to solve for that. So I have 4x minus y plus z equals 5. So I need to move 2 things over, right? I need to move the 4x over, and I need to move the y over. So I'll add that over. So I'll write minus 4x over here, and a plus y next to it. Okay, so they cancel out here. I'm left with z equals, and so I have negative 4x plus y, not equals 5, excuse me. So it was a positive 5, so plus 5. And now I can plug this in into the second equation. So I have 8x minus 2y plus 2 times negative 4x plus y plus 5 equals 1. All right, so distribute. And then I have 8x minus 2y plus, and then you have 2 times negative 4x, so that's going to be negative 8x. 2 times y is 2y. 2 times 5 is 10. Equals 1. So let's combine our like terms. We have 8x minus 8x, so that's 0x. We have minus 2y plus 2y, so that's 0y. And so basically it all cancels out. And we have this, 10 equals 1. Well, last time I checked, 10 does not equal 1. All right? So when you have something like this that equals a false statement, that is a no solution scenario. So the key difference between these two, the last 2 examples, is one equaled a true statement, 6 equals 6, and then the other one equaled a false statement. So if it's a true statement, it's infinitely many solutions. If it's a false statement, it's no solution. Otherwise, you're going to get a normal long problem like the first example. So if you want, feel free to pause this video and work this one out yourself. This video is running a bit long and I don't love this example, but if you'd like to work it out, the answer to it is 2, 4, -3. And if you have any questions, leave a comment below, or if you're one of my students, see me in person. Otherwise, thanks for watching, and I hope this helped, and goodbye.